Hey everybody, we're going to be working in section 8.1 on similar polygons, and the first thing we need to know is a similarity statement, because just like a congruency statement, if you remember when we did that, it's very powerful and important that you know how to use correctly. So I'm going to have you look at these yellow triangles here, and I'm going to write a similarity statement for that. So first of all, the first one is just you put the triangle symbol out front and then you name it in any order. So I'm just going to use triangle FEG. And then the similar symbol, it's kind of like the congruent symbol, but it's just the squiggly thing from the top. No equals, because they're not equal, they are similar. So there's our symbol for similarity. And then you have to match it up. So triangle FEG. You can see the way it's positioned, it didn't flip or turn at all, so it's similar to triangle KHJ in the same order. Alright, so there is a similarity statement. Of course, with the triangles, you need the triangle symbols out front here, as you can see we put there. Alright, so then, if you look over on the right side, you'll notice in blue here that we have some quadrilaterals. So when you're naming them, you just pick one letter and go around clockwise or counterclockwise. So I'm going to just pick on the left side D, A, B, C. And you could pick any order there. But then the second one, of course, has to match up to that. So D corresponds with T. So I'm going to start with T and then move around the same way. So T, Q, R, S. And there is another similarity statement. Again, these are very powerful because they can tell you, like segment FE, which is here, and KH are in the same order there, that they correspond to each other. So we're going to be using these similarity statements a lot. Or angle C and angle S, it would be C here and S, that they correspond. Also remember with similarity that angles are congruent and sides are proportional. So we'll get to that in just a moment. Alright, so notice on the top of the page here, I have a similarity statement for the pictures. Triangle QRS, which we have here. QRS is similar to triangle ABC, which is over here. And it asks us to list all pairs of congruent angles. Remember, angles are congruent when they're similar. So I don't even really need a picture here. You can see just by looking at this that angle Q, since it starts with that, and angle A are in the same spot there. So if it says to list all pairs of congruent angles, one pair would be that angle Q is congruent to angle A. Also in the middle here, R and B. So angle R is congruent to angle B. And then the last one, S and C. So angle S is congruent to angle C. Alright, then this part is going to be different, and important that you write down. Write the ratios of the corresponding side lengths in a statement of proportionality. Make sure you write that down. Because we're going to name the sides but write them in a proportion. Notice a statement of proportionality, so proportion is what we're looking for there. Again, we can look at the picture, or even more helpful will be our statement up on top here, our similarity statement. So QR, I'm going to write first, is to what? So you can look at the picture, or you can look over here, QR is to AB. I could put this upside down as long as I put all of them upside down, and just so we're consistent in what we do. So that ratio is equal to another one. Looking back up top here at our similarity statement, we have RS and BC. So RS is to BC. And then the last one will go QS. Side QS is to AC. That should be AC. I used all the QRS's up top and all the ABC's down on the bottom. But if all of these were flipped upside down, that would be okay as well. That would also be accurate, and it doesn't matter which ratio we write first, just so all three are there. If these were quadrilaterals, then we would have 4 parts to our statement of proportionality. All right, the next thing we're going to learn about is scale factor. We used scale factor a little bit before when they gave us a scale factor, like if it's a 2 to 5 or 3 to 4, whatever it might be. But now we're going to find that. So again, you'll notice off to the right that they gave us a similarity statement, and that is always very helpful. And that shows us that TRS from TRS in that order corresponds to ZXY in that order, so we can see they're positioned the same way. Nothing has been turned or flipped at all. So for a scale factor, we need to know, notice I'm calling this one object A on the left and then object B on the right. So it just depends if they're asking for A to B scale factor or B to A. And they can ask that in different ways. So we'll just say A to B first. So that means I'm going to take any sides that correspond to each other, like in their similarity statement, TR and ZX. So TR is over here, ZX is here. So if I'm going A to B, that means I'm going to put it in the order of 25 to 15. So I'm going to write that down, 25 to 15. And then we just write that as a nice reduced fraction. We can reduce by 5 on numerator and denominator. So we would get a 5 to 3 ratio or a 5 to 3 scale factor. All right, now if we're going to be asked to do that instead of A to B, they ask to do that B to A, then we would just look at corresponding sides again. Again, I'm just going to pick different numbers here. You could use any of them as long as you know they're similar, which they told us. So, like RS and XY. Well, RS is here and XY. But again, notice B to A, so that means we want to do this one to this one. So B to A would be a 12 to 20. So I'm going to write that down as 12 to 20. And once again, I would reduce that, and I can divide each of those by 4, and I get a 3 to 5 ratio. Now, over on the left here, we got a 5 to 3 ratio, and that's basically the same thing as a 3 to 5 ratio. It's just a matter of what order you're putting it in. All the sides need to be in the same ratio in order for them to be similar, which again, they told us that, so we knew they all were. So all sides are going from bigger to smaller. They're all 5 to 3, and going smaller to bigger, they are all 3 to 5. So those are the scale factors, or it is a scale factor for this problem. All right, notice here again, they're giving us a similarity statement. We need to look for that and use that to help us. So again, they're saying triangle DEF, so we look at the way it's positioned, DEF, similar to triangle MNP. So again, they're sitting correctly. They won't always be, but they have been in my examples. They're positioned the same way. Nothing has been turned or flipped. All right, this time they're asking us to find X. So well, here's X, and we need to figure out what that length is. So they gave us a lot of information. We did problems like this the other day. So we're going to continue to set this up as a proportion. So it doesn't matter what pair of sides you use. I do need to use X, of course, in my proportion, and that corresponds, well, that's EF, that corresponds to NP, which is this one. So X to 30 is how I'm going to start my proportion. X is to 30 as, and then we can use either this 15 to 18 because we know both those numbers, or we can use 20 to 24 because we know that pair of numbers as well. And again, there are many correct ways of setting up a proper proportion. This is just one way of doing it. All right, so x is to 30 is how we started. So that is left to right, kind of the way my pictures are. So I'm just going to use the smaller numbers here, 15 to 18. All right, so we have our proportion. And just like we did before, we're going to do our cross product. So we'll take 18 times x, and we'll take 30 times 15 to write our equation. So first 18 times x, I'm just going to write as 18x, equals 30 times 15, so that's 450. Oops. And then divide each side by 18. And so 450, whoops. All right, and after we divide that, we get x is equal to 25. So that is my answer. Whoops, 25. All right, and then the last slide I have here, it has these two triangles here similar. It says in the diagram, triangle TPR, so on the left side TPR, is similar to triangle XPZ, so XPZ. So that again tells you what corresponds to what. Therefore, this T corresponds with X, the P on this side corresponds with the P on that side, and R with Z. And it says to find the length of the altitude, PS. So altitude is right here, PS. The altitude are the lengths that go from a vertex perpendicular to another side. So we have an altitude drawn in here. And of course, the PS is an altitude as well. So they want us to find that length. So whatever scale factor or ratio that is used for the side lengths, like this 8, which is the whole thing, of course, is 16, would correspond, well, the 8 would correspond to the 6, but the 16, which is the full length, would correspond to the 12. So whatever ratio they are in, the altitudes will be in the same ratio, just as if it were a side. So we can find what those would be. So we could use like the 8 here with the 6 because they correspond. And we would end up with a 4:3 ratio, scale factor. Or we could use the full length of the 8 and 8 together, so 16. To the 6 with 6, which is 12. And notice we still end up with a 4:3 ratio. So regardless, we have a 4:3. The sides are in a 4:3 ratio, and that's looking on right to left, kind of the bigger to the smaller. So we want to set up a proportion. You can use any of the numbers I've used so far, 8:6, 16:12, 4:3, any of those. I'm going to use the reduced ones, 4:3. So then, this x right here is what I'm looking for, the length of that altitude PS. So 4 is to 3, and that's right to left, as the 20 is to x. Okay, so the 20 here, it corresponds, because we did the sides 4 to 3, reduced of course, is to 20 is to x. So we have our proportion. So now we can use our cross products to solve. 4 times x is 4x. 3 times 20 is 60. Divide both sides by 4. And we get x is equal to 15. So the length of PS is 15. That's the answer we would be looking there. So the altitudes are in the same scale factor, using the same ratio as what the side lengths are. So you'll be using that in part of your assignment today as well.